Chastity, welcome to the Leanpub launch video for Assembly Arithmetic Algorithms DOS, the 16-bit DOS edition. I was wondering if you could take a moment to talk to us a little bit about yourself, about who you are and where you're based and what you do, and what your book is about and who it's for.
Yes, thank you for asking, and thank you for contacting me. So I am Chastity White Rose, and I am an author in Lee Summit, Missouri, which is a place most people have never heard of, but it's here in the Midwest, a little bit south of Independence, Missouri. And I'm highly autistic and I'm transgender. That's the thing that causes most people to dismiss me because I'm weird looking. But when it comes to computers, I've always gotten delved into the world of computers. So I was always writing something or doing graphic design or computer programming, that sort of thing. A very isolated, lonely world is the way I live typically. And yet I care about, free software. I care about people knowing how the computers work, how the math works. And I care about important issues of our day and social issues, obviously animal rights, for example. So I've written books about all kinds of topics. But what I've noticed, and this is what got me into Leanpub, is the books that I tend to read, the books that I was buying, the books that I was reading were all about computer programming or like how to use Vim or Emacs or something, or it would be about how to play some game or something. Always a how-to book. That was what I was interested in because I wasn't really one to just sit and read a novel, though I've done that a few times. I read this romance novel and it was very weird. But anyway, so I was always interested in a book that tells me how can I do this and can teach me a programming language. I'll have to say the best programming book of all time was the C programming language by Dennis Ritchie and Brian Kernighan. Partly just because it covered the entire C language and the C standard library. Like I just haven't found a book that really matches that level of sophistication. And we are living in a time now in 2026 where people today are not like they were in the 70s, 80s, 90s. And I'm very retro. I'm very old fashioned, where I think that the reason I became as good at technology as I am is because in the 80s and 90s, um, there was these computers, they had only floppy disks. Some of them had no hard disk and very primitive text editors. And I had like a DOS 3.2 manual or whatever. And I learned to type in commands and read a manual on how to use a computer. And I had been given computers that were older than I am. I was born in 87, but people were giving me old computers that were just junk to them during the 90s. And so I started learning computers that way while everybody else was like, ooh, here's a point and click and here's Minesweeper. And Minesweeper and Solitaire are the best games ever to exist in Windows, by the way. But I was learning how to, write things, and I was learning computer math and the binary numeral system. My interests were in the low level details about how computers work. And I started getting into technical writing. I started trying to write books about programming. I wrote Chastity's Code Cookbook. And I even wrote a book about Markdown, the markup language that's used to publish books and all kinds of documents. I wrote a book about that. Um, and I started realizing people need to know some of the things I can tell them. Because if they know how to use Markdown to format their documents in a portable format, they can, for example, reduce their dependence on a specific vendor. They don't have to use Microsoft Word or some proprietary software that some company can take away or force you to pay a license fee forever. So I was very concerned with, business practices, screwing the customer over basically. I didn't like that. I don't like the corporate world. Um, and I I actually attended Full Sail University as an online student, and I started out in the game business and esports science program. So to learn about the business of the video game industry, maybe get into the video game industry, that was kind of my idea. But there was so much about money and monetization and marketing, and so much about how to get money out of people. And the things I was reading were things that I'm like, I don't agree with. I don't want to be in this industry, but I always was getting the highest grades on my writing assignment. When I had to write an essay on something or some story or even a script of something, I had to write a short screenplay. Um, I was always getting good grades on those assignments. And I realized, well, I'm already a writer. So then I switched to creative writing. And then I got into storytelling and I started learning about, different software and tools. Of course, I always found better open source tools than what the school was promoting anyway. Um, but I started really wanting to share my knowledge to free people from proprietary software and for people to learn how computers work, because now we live in this time where everything is AI. It's like, oh, well, if you don't know how to code, just tell AI what you want and have it generate code for you. And the problem with that is not just, the fact that we can't really control what AI does to a very good degree. The problem is that if everybody's relying on AI to do all their thinking and coding for them, then they're not learning it themselves. And what happens when there's a certain skill that nobody's learning? Then, when the generations pass, where the people who know that, they all die, and there's nobody who can replace it. And I realized that in order to help keep the technology knowledge in the world, I wanted to share what I knew. I wanted to share about how computing was for me back in the time of DOS and then into Linux and stuff, and how I learned to troubleshoot things myself. If something's not working, I find, okay, what commands do I need? What documentation and why do these commands work? Not just copy pasting some commands on some forum, but looking up the documentation and what the command line arguments are and why does this work? And so basically, in order to really have control over your computer, which is essential these days, because you have to have a computer to apply for a job, to file your taxes, to pay your bills online, to email people, to design graphics that are printed, because everything's done by computer these days, and writing is no exception. But, books are not copied by hand anymore, thank God, because that was a very slow process. But now we have the technology that we can write things, big things, and reproduce them perfectly, copy files, send files. We have more capability than ever to write things, to document and teach people things, besides video recordings like this. And yet people are not making the best use of it. If you think about it, people make a lot of entertaining videos, which is fun, and people do write a lot, but it's scattered on social media. And that's what I got frustrated with, is that on Facebook, you see something show up in your feed, and then you later on, how to get back to it. Like, where was that? How do I get back to that? I've had that trouble. And I also have been very concerned with the decline in physical bookstores. Bookstores are not staying in business, and some of them are closing down more and more over the past few decades, because now we have both the problem of ebooks. People are buying, ebooks off of, Amazon and Google and all kinds of things. And so the people aren't buying physical books very much anymore. But there's also the fact of illiteracy. People are not reading like they used to be. They aren't, it's not emphasized as much, because now that people have videos and we have video games and things that I like, but people are no longer reading like they used to. Before all these modern distractions and cell phones were invented, people used to read books a lot more. And even though I'm relatively young, I'm 39, I still come from a time when I read books. I learned how things work. I thought deeply and analyzed things, and I developed a very strong attention span to be able to just absorb information. And now I do everything I can to preserve what I've learned and write it down and continually refine it to try to teach people better. Because just as I've learned from many good books, I'm trying to pass on the knowledge. And I think that I have a unique ability to do so. I always found the hardest part was just trying to communicate it to non technical people. I'm trying to help people become technical people who learn how to use free software and learn how to write computer programs for themselves. And I think one misconception, though, is people have this idea that you do computer programming as a job to be paid. And I have to say, that's probably not going to work very well anymore. Back in the 70s, 80s, 90s, you could probably make a decent living as a programmer. In some places, you probably still can if if you are in the right field. But I think it's something everyone can benefit from. Even if you're just writing small toy programs to do simple tasks or do something entertaining like simple animations or whatever, because it's like a game. To me, this idea that you can control everything a computer does, you can allocate your memory, you can set the variables to whatever number, you can create loops. So as it loops from this number to this number, you can do this. You can print this text, or you can draw pixels or other shapes along some path. And you basically are creating all these amazing things. It's basically like Minecraft creative mode. It's like when you're playing Minecraft, the game, and you're just building things. And that's what programming is like to me. And we're all doing it. We're all creating something, whether we realize it or not. Whether we're building up our characters in a video game, or whether we're writing a book, or whether we're writing a program that does something, or whether we own our home and we're doing home improvement and building things and organizing our stuff in our houses, we're always creative. And people don't often think about the creative element, and it's still in our nature, despite what our jobs do to us. Because when you're at your job or you're paid, you just do whatever your boss tells you to do. Whatever the company wants, you have to do that. And in spite of how busy I am with my Walmart job, I really try to retain my humanity, my creative spirit. And so whenever I have a night off, I'm writing my next book or writing some cool program to do something. And this DOS assembly arithmetic algorithms, it's kind of the start of a series because in fact, I would say the reason I wrote the DOS book first is because DOS, the operating system, came first, and it was very simple. Back in the DOS days, you had very limited memory. You didn't typically have a point and click mouse. Everything was done by typing commands. Even the text editors of the time were just using the keyboard. And during that time, you could do something in DOS that you couldn't do in Windows or Linux even today. You could directly access video memory, or the address of where the command line arguments are passed to the program. You had full control of the memory. It was less memory, but you could control the video memory, you could control all kinds of things, and there were interrupts that you could call if you could find the documentation, which was always difficult because there are a lot of out of print books, some of which I even own, that would tell people, what assembly interrupts to call to get certain things done in DOS, to change the video mode, to change the color of text, or to get input from the keyboard. And there was this one guy, Ralph Brown, who compiled a list of as many DOS interrupts as you could. And the interrupts were interesting because they were basically something that the DOS operating system, and in some cases the BIOS, not the operating system, but the BIOS of the PC itself, had certain functions that were just right built into the ROM of the computer itself.
Hmm.
And so by calling the right interrupt, You were basically doing a function call, but one that was already part of the computer, part of the operating system or part of the BIOS. And one of the benefits of that, and this is something that one of my criticisms of even Linux today is it's gotten way too complicated because now Linux suffers from what's called as dependency hell, where it's like, oh, well, you have this function, but this depends on this other function. And so it depends on this library, but this required this version of this library. And now we have to have package managers just to make sure our software works even in Linux. So we have the Linux version of the DLL hell problem that exists in Windows, where you're missing all these DLL files and you don't know why. But in DOS, it wasn't like that. You could write these tiny .com programs that would be less than 100 bytes that could do more than a C program compiled on Linux that was 100 kilobytes. You could write a hello world program in less than 30 bytes because you're simply defining your data and doing a system call with certain registers. You could do hello world, and you can print integers and do all kinds of things. And I have been developing a cross-platform library, which I call Chastelib. And what I do is I write the same functions that do the same thing for Linux, DOS, and Windows. And I've written some programs, including one that's in the book. In chapter 10, I have chase text, and I still feel like I need to expand on that because it's a big program, but it's a command line hex editor that can open a file, seek to an address, and read or write bytes from that address. And you can use it as part of the script as a bash or a batch program. You could literally open files, modify bytes at certain locations, and do all kinds of things. Basically, to access a file just as if it's memory. Because in memory, you just like, oh, let's get a byte from here. Let's, set this byte here. And part of the reason for doing a command line hex editor, especially in DOS, is that in DOS, you didn't have like the graphical user interfaces like you have in Windows and Linux. And so every program you had was either something that you ran a command and it just did it as part of the script, or you had a text mode interface where you navigate around in text mode. Like for example, the if you remember the MS DOS editor, it was like a very simple text editor, probably the best text editor that Microsoft ever made until they kind of went to crap later in decades. But it was so easy to use. Like there were very few menu options. You could open files, save files, and I used to write programs. I used to write huge documents in that editor. And the text mode interface was easy. Without having to use the mouse and slowing you down, you could just use the keyboard and navigate, and you can build a muscle memory. And it was just incredible. But the reason that I wrote this book is that it's passing on this knowledge, and the book covers several things. It covers, okay, here's how you assemble a program, a hello world program. And then here is how I write a function that can switch between different strings and print different strings. And then I introduce functions one by one, like, oh, here's a function that can print an integer, whatever number you have loaded in this register, you can print it, but in various bases. So decimal, hexadecimal, octal, base 36 if you want. And it's very flexible. In fact, for any C programmers who happen to listen to this, I actually found the C programming language, which it's cool. I found its input and output facilities limited. I found printf was specifically geared only for traditional human understanding. It was meant to, print integers and decimal and occasionally hexadecimal and octal, or to do floating point numbers that are, some number point something for scientific purposes and managing money and all that. But there's so much more beneath the surface that is waiting to be discovered. And I found that even though C has been my main language, there's so much you can access in assembly that you can't access directly from C. There are instructions, for example, to rotate the bits in the byte. There's all these bitwise operations. There's the push and pop instructions managing the stack. And none of that can you access from a high level language. And one of the things I emphasize in the book, I remember, is the usage of pointers and memory addresses. Because back when I learned programming, I was learning, basic and C and then later assembly. But I found out that other languages like Python, Java, JavaScript, they all were like wouldn't have pointers. They would have arrays that were these object-oriented things that you could initialize and stuff, but you could not achieve the same speed as you could with pointer arithmetic. In C and in assembly, you can literally say this variable or this register points to this address. And then you can add and subtract from that address to go forward to the next byte or backwards to the previous byte and just navigate in a sort of sequential way that you can't do with array arithmetic. Because when you do array arithmetic, it's wasting cycles because every time it's saying, oh, well, this memory address where this array starts plus your index, and it has to do that addition every cycle loop. And when you have a loop that goes billions of times, that's way slower. It's way, way slower. And contrary to what people say on Reddit forums, humans can write assembly language that is faster than what a compiler can generate. And I know because I've done it because when you have access to assembly language, then you can to control the registers, and register to register operations are faster than between memory and a register, and you can use fewer memory locations and just reuse registers, which of course requires you to plan in advance what registers you're using. And most humans, they don't want to spend the time to do that. And if you're being paid for your time as a programmer and you're given a specific task you have to accomplish quickly, assembly isn't for you. But if you're doing it for the joy of it, if you're writing programs like it's a game and you're just trying to get that high score, how well can you do? How fast can you get this? Assembly gives you unlimited freedom. But
I think that's probably a great place for us to wrap up because the joy of programming that comes through very much in your writing and in what you've been saying here. And I want to say to anyone who's watched this, the writing in the book is just as clear as Chastity's writing in speaking in person, and just as structured, and it's just a joy to read. It's very clear, and it's like there's like example programs that you can find online. There's an explanation of why DOS, which you went into a little bit here as well, and there's like, and I know how hard these. I mean, for maybe not for you, but for most people, these kinds of books are very hard. They're hard to write well, to get well, and like for someone who is being introduced to the thing for the first time. Particularly, you mentioned earlier, maybe the reader might not be a technical person. If you're not a technical person, but you are interested in that joy, learning that joy of programming and the kind of step by step and how things work, this book is a great. Well, I guess I was going to say this book is a great book for you, but I guess this is just a great place to start because there's going to be more books coming in the series that I learned earlier in this interview. So thank you very much, Chastity, for taking the time to do this today. The book is Assembly Arithmetic Algorithms DOS, 16-bit DOS edition. I recommend it to anyone who just gets the joy of programming from how Chastity's been talking, and wants to learn like a very well set out, very thoughtfully written, very clear book. So thank you very much, Chastity, for taking the time today.